You all welcome today my session. Our topic is model using linear and quadratic functions. So this is also the very important section in our course unit. And learning outcomes of this session. After completion of this session, you should be able to use linear models to determine the cost, revenue, profit, demand, supply, break-even point and equilibrium point. And also you should be able to solve different business-related problems using linear and quadratic functions. Right? So when we move to the first part, that is introduction, in this session, I will explain to you how we can use the linear and quadratic models to describe or explain or answer the business-related problem through or via identifying the required functions. Because we know using linear functions to describe or estimate any relationship with different or between the two variables or different variables. So we call that is the linear model. So here we study in this section, we highly focus the several kind of model. That means the linear and quadratic functions model with cost function, revenue function, and profit functions. So already you know the meaning of cost function. We know cost function model, the cost of the producing goods or providing services represent. So normally it's expressed, if it is we consider as a linear function, then we know it's if it is the linear function, we know the general form of that. If it is linear, we know we have to use, so we know that function should be y equal mx plus c method, right? So then we know the cost function we normally use to represent the c as the notation. So then here we can use our cost of the variable, our unknown variable. When we use the unknown for represent the unknown variable, if we use the x, then we can see, right, mx plus c. In this case, plus b or c, right? In this case, if this b or c, we know when we apply this as the cost function to the cost function, this part is the constant value. That means it should be the fixed cost, because we know our total cost also consists with variable cost and the fixed cost. Right? That means in the linear cost function, there are two parts, fixed cost. Normally we know fixed costs such as rental, insurance, salaries, other benefits, etc. Right? And variables, we know that variables also depend according to the number of units that you produce, right? So then this cost, variable cost also depend or vary based on the number of units that we are producing. So then adding these two types of cost, that means total cost of also total cost function, therefore the consist with the variable cost and the fixed cost. And if we move into the next function, that is revenue function. So revenue function also revenue functions model is the income received by the organization when they sells their goods or when they sells their services. So this function normally we represent by or using the notation as X, right? Notation as R, right? Revenue, and also we can put the name of our variable, unknown variable, that is X, right? So we can change it, and our revenue function then equal to X multiplied by fee, XP, because in here X is the number of units which we sell and P is the per unit price. P is the per unit price. So however, we know the price, right? Price also, no, price is not always fixed, right? It can be varied. So therefore, for this reason, the unit price is often given in terms of demand function, right? So that means demand function also represent the relationship between price and the quantity. So this function gives the price of the items in terms of number of demanded over a given period. So then therefore, when we find out in the revenue function, right? So we need to, or sometime we need to use that demand function, right? Because based on demand function, always our revenue function depend. And next type of function is profit function, right? So that is also too familiar to you. Profit function model the profit made by manufacturing or selling, producing or selling goods, or by providing the services. And also profit represent the amount of money left over after goods or services are sold and costs are made. So therefore, in here, in profit function represent the profit, and this profit we can calculate or determine when deducting the cost from the revenue, right? So then already we know we identified our revenue function as R, right? Rx, if our unknown variable is X, right? And we know that our cost is C. Then if we use the P as the profit, then PX should be RX minus CX. Right? That means revenue, the cost minus from the revenue. Okay, so you know how to make the profit, right? And next, that is the very, very important point, right? In this session, right? I need to, yes, okay, break-even point. Then the break-even point in any business is the point at which a organization or company making neither a profit nor an incurring loss. No profit and no loss. Therefore, at the break-even point, the company has met all its expenses associated with the manufacturing or providing services. That means our total cost equal to our revenue. Both are similar, equal, therefore no profit or no loss. And however, when we calculate identifying this break-even point, there are two methods we can use. So through the graphically we can identify this for break-even point, as well as algebraically way we can identify that if we know the cost function and the revenue function. So X coordinate of the break-even point give the number of units that must be sold to break-even, right? Break-even. That one we can take from the geometrically, that is, that means through the graph. The y coordinate gives the revenue at that production and sales level. So after the break-even point, the company will make a profit. Right? That means after when we passing through the break-even point, that means they can earn the profit. And also profit will be difference between its revenue and its cost. That means in graph, we can identify the what is the profit generated area. That means difference between cost function and the profit function. Right? We will do some examples. Right? And one more thing I want to explain, that is another rule or the model. Right? Market equilibrium. Market equilibrium occurs when the quantity produced equal to the quantity demand. Demand equal to the supply. Right? Quantity produced equal to the quantity demand. Then the quantity produced at the market equilibrium is called the equilibrium quantity, and the corresponding price become the equilibrium price. And mathematically, market equilibrium occurs at the point where when you use the graph, where the graph of the supply function and the graph of the demand function intersect point. The intersecting point of the supply function and the demand function. So we can solve problems of this type of either also graphically or the algebraical. Right? We will do later some examples. Right? So until I will do the examples, we have to explain another points, right? Another models. Right? So marginal functions, right? Marginal functions. And under that also marginal function, as the marginal functions, we can identify the marginal revenue, marginal cost, and also marginal profit. So we know the slope of the function, but remember that in here we consider we consider only straight line. Right, the straight lines function, that means the linear function. Right? So if our function is linear, then we know that any point on the slope should be equal. Right? Any point on the function is equal to any point on the function's slope same as other points, right? So therefore, marginal revenue, right? Marginal revenue is the slope of the revenue function. But we want to remember in here, right? If it is the revenue function, right? If our revenue function like this, that means if it is the straight line, then any point of this revenue function slope is equal. That means marginal revenue is equal in this type of revenue function. Right? But it can be differ when our revenue function becomes the other type of function. In as example, the quadratic function like, okay? So another curve like, right? So we will discuss this part later. So then the marginal cost mean also, right? If our cost function is again the straight line, then the slope of this function is give us the marginal cost. And similar to the these two, also it is similar to the profit. That means slope of the profit function give us the marginal profit. That means slope, right? Slope, the function slope also represent the marginal value, right? Marginal function. And then, yes, what is in here? We can't look at me correctly. Yes. Next, I will explain to you how we can find out the maximum and minimum point of the quadratic function. I think this part also we discuss in our what we called our algebraical lesson, right? Algebraical lesson. So I think you need to remind that one, right? For this session, I'm not going to explain again this one, right? So now look at the some applications, right? Applications for the applications in linear and quadratic functions as the models, right? So linear models and quadratic linear functions and quadratic functions and models, right? We can use this linear and quadratic functions model to solve our business type problem. So now I am going to explain some examples to you. Yes. Yes. It's in the other side, no? Can we rotate that one? Little bit hard, no? No. Anyway, I'll do that, right? So shall we go through this example first? Right? In this example, it says a manufacturer sells his product at 18 for units, rupees 18 per unit, selling all he produces. Right? That means selling price of per unit equal to 18 rupees. And his fixed cost is 1,800 per day, and the variable cost is 12 rupees per unit. Okay, 12 unit per unit. And based on this scenario, based on this given information, right? So now you can learn how to write down the total cost and total revenue function and other things. That means how we will learn draw the graph of cost and revenue function on the same axis by considering the sales range or sales range from 0 to 800. And also this using the drawn graph, right, we can find out the other things, right? So first I will show you how we can draw this, how we can draw these two functions on the graph, right? So shall I summarize in the given information? Per unit selling price is 18. Yes, per unit selling price is 18 rupees, and per unit variable cost is 12 rupees, and fixed cost is 108. 1,800. Okay. So then first when we write in the I will go here. When we write in the cost function, you know, total cost function equal to fixed cost plus the variable cost. So then I can write cost function as this way, right? Cost function equal to fixed cost 1,800 plus variable become 12 into number of units. Here we know then number of units is the X, so we can write this one. Okay, and also our revenue function, right, R, it's become per unit selling price is 18, then 18x, and then we know the two functions, cost and revenue. So then other information, other information already given is we need to draw these two functions on the graph when considering our X value between 0 to 800, right? 0 to 800 because it is given information. So then you know to draw any kind of function or line on the graph, we need coordinate points, right? Coordinate points. So therefore, just first we need to calculate to compute the coordinate point for these two functions. In here, when I use in the some values as x, because we need to, here is given, we need to get the we need to consider the range as 0 to 800. So shall I use, take in here 100 first, no, 200, 200, 400, 600 and 800, right? So 4 points here. And when I find in the cost coordinate point for the cost function relevant to the cost, for the each values given in here, each value we consider as the x, right? So when then x equal to 200, right, we have to calculate cost function when substituting these values in the cost function, right? So just I take in the 200, you know, we need to multiply to get the variable cost. We need to multiply by our 200 by the 12, and then we have to add fixed cost, that is 1,800. Then all together number is 4,200. Right? And for the 400, if x equal to 400, then we calculate 12 multiplied by 400. Now it's become 4,800. Then we add in variable cost here. It's equal to 6,600, right? And next, when I move to the 600, when x equal to 600, then I multiply by 12, the 7,200, and when I add in 1,800 to that, altogether 900, right? Then if it is 800, what has happened? 800 multiplied by 12, and then I add in the 1,800, it becomes, am I correct? 11,400. Yes, I want to check it again, right? Shall I check? 800 multiplied by 12. Then add 1,800. It's okay, no? Right. And this is a cost function's value. Then at the same time, I can find out the revenue function values, right? So just, yes, I didn't take 0, no? It's all right, no? Okay. And 18 multiplied by 200, right? Then 3,600. When 400 multiplied by 18, that means revenue become this value, right? And if x equal to 600, what is the revenue? 10,800, right? And when x equal to 800, what is the revenue? Multiplied by 18 become 14,400. Right? So now we have some coordinate points, and using these coordinate points, we can draw our graph, right? But remember, we can graph this one, but we need to graph this two functions on the graph. We need the graph paper, right? Otherwise, we can't get the correct value for the correct answers for the given question, right? So remember, in here you need to use the graph paper to draw these things, right? Otherwise we can't get the exact value. So I will show you in here. Then, because when we are naming these two axes, x axis is the unit, right? Number of unit. You can write in here number of unit. And y axis also we represent the cost and also our revenue in rupees, right? Both in rupees, right? So then I original point here 0. So when I check in here, 200 is the smallest value, then 400, and next 600, and next 800, right? And for the y, we have to get the maximum 14,000 value. So just I write in here then 2,000, right? I put in here only 2 instead of 2,000, right? And I put it, therefore I need to put here 1,000. Okay, so 2, 3, 4, difficult, no? 5, 6, 7, likewise. Okay, so then yes, when we first draw in our revenue function, when x equal to 200, the value is 4,000 and yeah, this value. No? But remember, just when x equal to 0, just we can know the cost value, because that means x equal to 0 mean just our total cost equal to only fixed cost, right? Total cost equal to fixed cost when we will not produce in the produce in the any product, right? So that means when in axis we can write here 1,800. Okay, and one more I'll here when it is 400, it is 6, no? Yes, okay. And then it's become the 800. No, 600, it become 9, likewise. Okay, you can see it. It goes like this. Okay, and our revenue function is starting when it becomes 0. We know 0, no? Right? When our x equal to 0, our revenue also 0. But when our x equal to 200, it becomes in here, no? That value is less than the cost, right? And it's become 400. Now here, no? Yes. Anyway, you can see that the equation got like this. Okay, so remember, I in this blank paper, right? White paper, I can't draw it correctly, right? Proper way. So remember, if I have the graph paper, or you have the graph paper, we can draw it very correctly, right? So in as the straight line, you can see straight line. Okay, because both functions are straight, right? Both functions are simple linear functions, right? Linear functions, not the curve, right? So then when I move into the questions, what they are asking, through this, so by using this graph, we have to find out break-even point. Now we know what is the break-even point. Break-even point is no profit, no profit, no loss, right? Padut ne, labat ne, right? So then we know in here, no profit, no loss mean this one, right? But in here, very sorry, because I can't get the exact correct value through this graph, because just this is the draft one, right? So this is no graph paper, so I can't do it correctly, right? But remember how we can do find out that, right? So when we consider in this intersection point, that intersection point mean the intersection of cost function and revenue function, and we draw in this the what we call here vertical line to the our x-axis, then we can get the number of units where the x-axis is touching this vertical axis, and from the same intersection point, when we start in the intersection point and we draw in the horizontal line to the y-axis, then where the point is that line is touch the y-axis, that is the cost and or both cost as well as revenue in the break-even point. Okay, so this one, so we can find out this. Here I want to explain you how we can find out this break-even point through this graph. But remember, this break-even point also we can calculate with or calculate by using the algebraical expression. So algebraical way. Okay, so that means here we know both is equal. So when I equalizing cost function into the revenue function, right? Equalizing cost function into the revenue function, then that is the break-even point, points x, because both are equal. When here you can see when I see simplifying this one, this part becomes 6x, it equal to 100,800, then x equal to 300, right? So that means we know here 3 is the number of unit in the break-even point. And then you substitute in this x value on the revenue function or cost function, then we can get the total cost or total revenue, right? So it should be the similar to the same answer. That means the answers which we got from the our this graph, right? So this is the way how I did it, right? You can go through this one. Yes. Then it's asked the second question, right? Yeah, you can get the total revenue or function revenue or the cost at the point break-even point, right? At the break-even point. Anyway, I will explain to you how we, yes, the second question B, it's asking when x equal to 200, what's the loss? It's asked, right? So when it's equal to the yes, in here it is very clear. Through the graph you can understand very correctly. When number of units equal to 200, when we start in from this 200, right, and we draw in the vertical line to the cost function and also the revenue function, then the difference between these two, right, because we can see in here which one is the large one, right? Largest one is in here cost, but revenue function goes in the down. That means we have here loss, not the profit, right? The profit amount is this distance, right? When we after identifying this one, then we can draw in another two lines, horizontal lines to the y-axis, right? So then this amount equal to the required loss, right? The required that is equal to when we producing the or selling the 200 units. Okay. So the same thing we can just take this value because this is our revenue function, right? In this revenue function, through the revenue function, we know we have to find out the total revenue, no? Right? So then in here asking the profit, so we can find out profit function first when deducting our cost function from the revenue function. When we deduct in cost function from the revenue function, then we can get the profit function. In here, shall I write it? That means what is our revenue function is 18x. Then we deduct in our minus in, no? When we minus in our cost function, that is this value 1800 plus 12x. Okay. So then we know our profit function, right? Our profit function, shall I write it another color? Our profit function then equal to, okay, P equal to minus 806x, no? 6x minus 1800. That is our profit function. Okay. So then when we apply in here instead of x our 200, right? So then we can find out the profit. that profit mean? That meaning here when I, in this our example, when x equals to 200, then 6 into 200,000 and 200, then minus in 100,000 and 100, then we know minus value answer. That means the loss and 600. Okay, so that is how we can find out it the algebraical way. However, we can find out it the graphically, right? And another question it's asking, when x equal to 600, what is the profit, right? So it is very easy now again, because just we go through here, we can find out the 600 in our x-axis, and we draw in the vertical line to the cost function, and we move it to the profit revenue function, then difference between difference between cost function and revenue function, right? So just we draw in the horizontal axis to the y-axis, then we can find this distance. That distance equal to the profit that we earn when producing or selling 600 units, right? So through graph, you can identify that one, or similar thing you can do when algebraically way. Shall I delete it? Okay. Then yes. Okay, so when x equal to 600, what is the value? Shall I calculate it? All right, that means I need to multiply 6 by again 600. Then it's become 3,600. So then according to our profit function, we need to minus 1,800. Then again answer also 1,800. That means when x equal to 600, our profit equal to 1,800, because in this point you can see our cost function is in the down, revenue function is the upside, right? That means the difference is the loss, right? So anyway, you know this part is the profit, right? But in this part, right, this triangle area is in the loss. This is the break-even point, right? I think you can understand that part. That's those things in very clearly. So then, any more question in here? Yes, no. Yes, final question is yes. Then the final question is asked in the different way. Same thing is asked in the opposite way, right? That means it's also given the profit. If our profit equal to 2,800, then what is our x, right? So you can see how this answer is asking, right? The output required. What is the output required to obtain profit 2,800 a day per day, right? So then here we know profit, we know total profit. So then how we can find out our number of output in here, right? So for that, that is hard to do this in our this through my drawn graph, because when we draw this one in the graph paper, just clearly we can identify the each point, right? So in here, then to answer this question, after you draw in your after you draw in your cost function and the profit function on the graph, next you need to just check which is the profit earning area, right? Which is the area that profit earning, right? In this case, you can see this blue colored area is profit earning area, right? And then next it's asking the when we earning 2,800, 2,200 no profit. So that means you have to check that this vertical distances were equal to 2,800. Right? Then we find in, after we find in that the vertical distance equal to that amount, then we can draw the line to the our x-axis. And after that you can find out the where that vertical line touch the x-axis. So yes, touch the x-axis, then that is the number of units that we want to earn that amount of total profit. So same thing we can do this, that means the algebra, not the algebraical way, we can do that as the when using the our when using the already find out equation for the profit algebraically way, right? Not the geometrically way, algebraically way. So this is our profit function, right? So then for this case, what we want to do, we need to equalize. Instead of we have to put in here given profit, right? Given profit. And then 2,600 equal to 6x minus 1,800. When we simplify in this one, shall we get the x value? Shall I do that? Yes. When we bring in this minus 1,800 into other side, all together become this value, right? Plus, yes, 4,200. Then to get the x value, we need to divide by this value into the 6. Okay, that means 700. When we simplify in this one, we can get x equal to 700. That means I will explain again, right? In this case, it's asking what number of we need to sell to earn the profit 2,400. So then this one we can get through the algebraically way. So when we equalize in our profit to the 2,400. For that, we have to consider the profit function. In this profit function is the 6x minus 1,800. So then that one is equal to 2,400. When we after simplifying that one, we can get the answer. That value is x equal to 700, right? So then we can give the answer for the question. What is our question? The output, right? The output required to obtain the profit 2,400. The output is 800. Right? No. Very sorry. What is the value? Yes, 7. No, we have taken 700. Okay, then 700 is the value. I think it is very clear for you, and now I will, shall I move to the next question? Yes, we did this one and these are the answers. Yes. Shall I do the section number, which one? What is our section in here? Section number 2. This one, no? Yes. First go through these sections, right? The example is the total revenue function, right? Total revenue function is given by y equals 100x minus 10 squared. Right? 10 squared. Then So yes, we can see, or we can know that equation is quadratic function, not the straight line, not the simple straight line. So that is this given, this function is y equal 100x minus 10 squared. That means it is quadratic function. Okay, so the quadratic function mean, because the x is squared now, this quadratic function mean our when we draw that one, then our this is the revenue. No, revenue function become how? Our revenue function look like this way, right? Parabola open down. Why? Because we can see our x squared values, sign is minus, right? If the x squared term sign equal to minus, then we have the maximum value parabola shape. And what is our given cost function? It is also the linear one. So then it's become the linear one. Okay. So then when we draw in this one on the graph, have they given some range? No. So anyway, shall we take reasonable values? Okay. Yes. In here I have no. So then here, right? So now we know to graph those two functions on the graph, we have to take some coordinate point, right? So it is wasting more time. Therefore, I will just show only one, right? So how to get the calculation for the 1 point? So then you can go through other, right? In here you can see. You can see this is our revenue function. This is the revenue function. This is the cost function. If our x equal to 20, that means we need to substitute this 20 instead of x in the revenue function, right? So when I substitute in this x instead of x, right? Then I need to multiply 20 again 20, right? That means square root of 20, no? 20 multiplied by 20 is become, sorry. It become 400, right? So 400 I need to multiply by again 10, right? So that means 4000 deduct from 100x, right? 100x mean 20 multiplied by 100, that means 2000. Am I correct? Yes. And in here 20 multiplied by 20 again is multiplied by 10, right? 4020. No, final answer equal to this. Am I correct? Okay. So I have some doubt. Give me 1 second. 20 multiplied by 20, right? Value is 400, right? So then when multiplying this 400 into 10, it becomes 40. And x mean again 20 multiplied by 100, 2000. No, something gone in here. So just mean, yes, there is some typing mistake here. So this revenue function, I think when I put in here, just this revenue function y equal to 10x minus x squared, right? 10x minus x squared. Now let's check. It's okay, no, 20, yes. So just I will change the work action, yes. Yeah, this one, okay. Oh, I need to write that one. Oh, how? Yes, this one given by y equal to 10x minus x squared, right? So anyhow, so just I will change that one, right? So now we can do that. where is our graph? Yes. Okay. This one, okay. Y equal to 10x minus x squared, right? Now you can see when I changed that one, okay? So some printing mistake there, right? So then this is 1600. Right? So when I move to the next one, 30, when we applying the 30 in our revenue function, 30 is when I square in 30, 30 into 30, 900. Okay? Then 10 multiplied by 30 means 3000. 3000 minus 900 means 2100. Okay, so likewise you can count or get all the revenue values, and also the cost function. You can compute the cost when it equals to 20, then 20 multiplied by 200, then altogether that means 200 plus 1800, altogether 2000. Okay, so likewise you can compute all the values. Then by using those values, we can draw the graph, right? In this case also, can we rotate this one? Little bit hard, no? So anyway, right? I will show you. Right? Then we graph in all the calculated to computed value for the revenue functions and the cost functions, right? So then you see that is the shape of our revenue function, and this is the shape of our cost function. Cost function is a straight line, and revenue function becomes the shape like parabola. Okay, so then I'm not going to explain you the I'm not going to calculate the exact value because of my graph, because I don't have the graph with the graph paper, right? So but I will explain you, right, how you can calculate those things, right? So when asked in the first question, in the first question it asks draw, yes, using the graph find the any break even point. Okay, so any break even point mean here we already now we know break even point mean no profit, no loss, right? So in here we can see two break even point. Okay, we have seen two break even points. This is the one. Oh, what happened? Shall I draw it again? Two break-even points. One is this one and this one. Okay, so then we know x-axis represent the unit, this side revenue and the cost. Okay, so then this amount is the break-even points x value. That means at the break-even point, number of units that we produce in and selling. And y-axis we can find out the revenue and cost also. Okay, same, both are similar. So then when you draw in the horizontal line this way, and you can find out the y value. And also you can draw in the another horizontal line like this, you can find out the value here. Okay, so then therefore we have two break-even point, that means x value and number of units and cost and revenue both are similar, right? So this is the one, another coordinate points. Okay, also you can get the units and the cost and the revenue. Okay, there are two break-even points. And next question asks in the sales range which will yield a profit for the firm. Yes, very clear, right? Which is the range that the company can earn the profit, because up until here, from we come until here, our profit revenue is this way, our cost is this way. That means no profit. Right? When we from starting point here, from here to here, what has happened? Our revenue function goes up, and our cost function this way. That means in this area is our profit generating area. Then after we come here, move to here, again what has happened? Our revenue is goes down, right? And but our cost is go up again. That means when you start in here to here again, the company earn loss, right? No profit. So then profit generating area is this one. Through that one again, you can identify the profit generating range of unit from here to here, right? You can see my pen, I am touching, right? X1 to X2, from X1 to X2. Profit generating number of units. And next, what is the question? The maximum profit the firm can expect it, and the level of output for maximum profit. So asking the what is the maximum profit that firm can earn, and also what is the level of output for that profit. Okay, two questions asking. First one is what is the maximum profit, right? So that anyway, it is very hard to find out through this graph, or also if you draw the graph in the graph paper, then little bit okay. So the problem is in here. I use another color, then you can clearly identify that one, right? Right, you can in here yellow color, right? So in this profit generating area, where the highest vertical distance, right? Make a koheda usama tana, right? So when I consider this one, right? So how we know that one, right? Just keeping our ruler in here and ruler, right? So keep in here, so we can understand which distance is highest, because we know when we move to the here, it's little. Here little circle. Okay, so then up to in here to highest point and here to highest point, then we can understand, right? So that means in this distance, that means when y2 and y1 distance is the profit, highest profit. And also we know that vertical distance, and when we draw in it to the when we move when we draw in the vertical axis to the our x-axis, right? Then where the point its x-axis is touching, that is the number of unit. And that is the number of unit. That means when we, shall I put in here x star, right? So then x star is the number of units that is equal to or generating the maximum profit. And also what is the maximum profit? Maximum profit is distance between y2 and y1. Right? So you can find out the value. And also this one you can find out with the algebraical way. Right? Algebraical way, that means so we know our profit function. Sorry. Oh yes, we can calculate to find out our profit function, because already we know cost function and also the revenue function. So then deducting cost function from the revenue function, we can find out the profit function, right? So then profit function, after we get in the profit function, so you can find out the highest point of the profit function. So here I will explain you. So what are the, yes, in here I have changed, no? I have changed my function, this one, no? Did you remember? I have function changed that one. 10x minus x squared, no? And second one is where is our, yes, 1880. So okay, here need to keep it in mind. x, no? No. Come on, I'll put in here, no? This is our revenue function. So profit function is am I correct? Yeah, no? So then you can see when deducting this cost from the profit function, from the revenue function, we can get the, this color is not clear. We can get the profit function, right? So then, shall I write in here P equal to, deducting this one, yes, that means minus x squared minus 10x minus 18, sorry, 1800 and minus 10x. Okay, minus x, 10x, minus x, and then minus 2x, 20x, and yes, here x squared minus 20x, and here minus 18,800. Okay, then this, it's also the quadratic function, right? This is also the quadratic function, and you can see this profit function shape is also quadratic function. Then you know how to find out the maximum point of this quadratic function, because already we have learned that one, right? With previous through the previous session, right? So in here at a glance also, you know, this profit function's s squared value is minus value, right? That means the squared term is minus coefficient, minus 1. So that means this, its shape is this way. That means that it has a maximum value. So then maximum point we can find out profit functions. So you know, minus b, no, minus b dividing by 2a. Okay, in here minus b mean again 20, because minus become plus, then 20 dividing again here minus 2, it become minus, it become the 10, right? So likewise, I think you can find out the profit functions maximum point, right? Okay, just go through this one again, right? Be careful about the signs, right? Be careful about the signs, and then after you taking, right, maximum value of the x value, maximum value of this profit function's x value, then you can find out the, when substituting that x value into the profit function, you can find out the total profit, right? So in this case, I'm not going to have, I know I'm no need to emphasize that thing. I want to emphasize the other thing in this here, in this lesson. That means I want to here explain to how to find out the answers for the given question.